In this video, we will discuss the discrete logarithm. Let capital G be a group under the binary operation star, and let little a and little b be elements of the group capital G. The discrete logarithm of little a to base little b with respect to the binary operation star is the smallest non-negative integer little n such that b to the little n star is equal to a. We denote this discrete logarithm like so, and we read log base b with respect to star of a. If such a non-negative integer n does not exist, we say the discrete logarithm, or for short the discrete log, does not exist. Discrete logarithms are one of the fundamentals of any cybersecurity protocol. The complexity of calculating the discrete logarithm for an arbitrary element in a large group is what ensures that a security protocol cannot be compromised. For small groups, one of the most naive methods used to compute the discrete logarithm is brute force. For example, consider the multiplicative group Z mod 7 under the binary operation O times with elements little a equal to 6 and little b equal to 3. Since there are only 6 elements in this group, we can simply compute the powers of 3 until we find one, if it exists, such that b to the n mod 7 is equal to a. In this case, the exponent little n that we're looking for is n equal to 3, since 3 cubed is equal to 27, which is equal to 6 mod 7. So, the discrete logarithm of a to base b with respect to the binary operation O times is 3, and we would write log base 3 of 6 is equal to 3. For this example, with a equals 6 and b equals 3, there was a discrete logarithm. However, if we keep the same multiplicative group Z mod 7, but change the value of a to 4, and change the value of b to 6, there is no discrete logarithm. It's important to keep in mind that even when working in the same group, different combinations of elements may not produce a discrete logarithm at all. To conclude this video, we will present the naive discrete log algorithm, which accepts as input a finite group G under a binary operation star and 2 elements little a, little b in the group capital G. Depending on the group G and the elements a and b provided as input, the algorithm will output one of 2 possibilities. If the non-negative integer n exists, the algorithm will output this integer n. Otherwise, the discrete logarithm does not exist, and the algorithm will output the discrete log does not exist. The first 2 steps of this algorithm are to create the variable n and assign it the value of 0, and create the variable c and assign it the value of 1. Next, we come to a repeat statement and enter a loop. The first step of the loop is the conditional statement if c equals a, then return n. If the conditional statement is true, then our algorithm returns n and immediately ends. However, if the conditional statement is not true, we proceed into the loop. The second step of the loop is to redefine the variable c and assign it the value of c star b. The third step is to redefine the variable n and assign it the value of n plus 1. We continue to repeat these steps until n is equal to the cardinality of the group G. Recall that the cardinality of a group G is equal to the number of elements contained in G. If n is equal to the cardinality of the group G and we have still not returned a value of n, then the discrete logarithm does not exist and we return this statement.